Let's practice balancing some chemical equations. The first reaction we are going to look at is aluminum bromide mixed with potassium sulfate. These two things react to form potassium bromide and aluminum sulfate. The first thing we want to do is check to make sure our formulas are balanced. Aluminum has a +3 charge and bromide has a -1, so the subscript 3 makes it balanced. Potassium has a +1 and sulfate and -2, so the subscript 2 makes it balanced. We do the same thing on the product side of the reaction. Next, we must identify our elements on the reactant and the product side. I draw a line down the middle and identify aluminum, bromine, potassium, and sulfate as my 4 ions. Remember, sulfate is a polyatomic ion, so it stays together as one thing. On my product side, I also identify aluminum, bromine, potassium, and sulfate. I write these in the same order so that it is easy to compare. Next, I must count my atoms. I have 1 aluminum. The subscript 3 means I have 3 bromines, subscript 2, 2 potassiums, and 1 sulfate, because it is one thing kept together. On my product side, I have a subscript 2 on aluminum, 1 bromine, 1 potassium, and a subscript 3 on the outside of the parentheses, meaning I have 3 sulfates. Starting from the top down, I see I have 1 aluminum on the reactants and 2 on the products. I must add a coefficient 2 in front of aluminum bromide, changing my aluminum reactants to 2. This also changes the bromines to 6. My aluminums are now balanced, but my bromines are not, so I need to add a coefficient 6 in front of potassium bromide on the product side. This changes not only my bromine to a 6, but also the number of potassiums on the products. Now that my potassiums are unequal, I must add a coefficient 3 in front of potassium sulfate on the reactant side. This changes potassiums to a 6 and sulfates to a 3. My aluminums are balanced, my bromines are balanced, my potassiums are balanced, and my sulfates are balanced. This means I have a balanced chemical reaction. Let's do another practice. This time I'm going to add sodium to water to produce sodium hydroxide and hydrogen gas. I add in my charges to make sure my formulas are balanced. Remember, hydrogen is a diatomic. One thing I notice is that I have hydroxide on my product side, but no hydroxides on my reactants. If I rewrite water as HOH instead of H2O, I now have a hydroxide on both sides, which I can easily count as a polyatomic ion. Divide my products from my reactants and identify ions: sodium, hydrogen, and hydroxide on both sides. Next, I count atoms. I have 1 sodium, 1 hydroxide, and 1 hydrogen on my reactants. Remember not to count the hydrogen both in hydroxide and alone. I have 1 sodium on products, 1 hydroxide, and 2 hydrogens. My sodiums are balanced, but my hydrogens are not. Therefore, I add a 2 coefficient in front of my water. This changes both my hydrogen and my hydroxide count on my reactants to 2. Now my hydrogens are balanced, but my hydroxides are not. I must add a coefficient 2 in front of sodium hydroxide on the products. This changes not only my hydroxide, but also my sodium. To finally get it balanced, I add a coefficient 2 in front of sodium. My sodiums are balanced, my hydrogens are balanced, my hydroxides are balanced. This means I have a balanced chemical formula. The last reaction we are going to practice balancing is a combustion reaction. Combustion reactions are typically the most difficult to balance, even though they only have 3 elements involved. Combustion reactions are also not a time to rewrite water as HOH, because the opposite side does not have a hydroxide polyatomic ion. Our equation here is C8H18 plus O2 goes into carbon dioxide and water, which are the only products ever made in a combustion reaction. I divide my space in half and identify carbon, hydrogen, and oxygen as my 3 elements on both sides of the reaction. Counting my atoms, the subscript 8 means I have 8 carbons, subscript 18 means I have 18 hydrogens, subscript 2 means I have 2 oxygens, all on the reactant side. I have 1 carbon, subscript 2 hydrogens, and 3 oxygens, 2 coming from the CO2 and 1 from the water. On the product side, our notes state to start with carbon and finish with oxygen, so that is what we will do. Starting with carbon, we notice that we have 8 on the reactant side and 1 on the product side. I must add a coefficient 8 in front of carbon dioxide, which leaves me with 8 carbons on the product side. I add a 9 in front of the water to give us 18 hydrogens. Now both my carbons and my hydrogens are balanced, but I need to recount my oxygens. Multiplying that 8 and 9 coefficients in, I end up with a final count of 16 oxygens from CO2 and 9 from water, which leaves me with 25. Because this is an odd number, I cannot get an odd number of oxygens on my reactant side with only an O2 molecule. Therefore, I must multiply every coefficient by 2 in order to get an even number of oxygens on the product side. This changes my subscript on water to 18, my subscript on CO2 to 16. Recounting atoms on my product side gives me 16 carbons, 36 hydrogens, and 50 oxygens. I must now balance this by adding a 2 coefficient in front of C8H18. That takes care of my carbons and my hydrogens. To balance the 50 oxygens on my products, I add a 25 coefficient in front of oxygen on the reactant side. Carbons are balanced, hydrogens are balanced, and oxygens are finally balanced. This leaves me with a balanced chemical equation. Now that we've taken notes and done some examples, please fill out the practice form on your teacher's website.